discuss about forming polynomials. Yeah, before starting the lesson, just one suggestion. If you feel that the voice is cracking or due to some internet issues, better use your phones so that you can have voice clarity. Now, exactly reverse of the previous topic, where we discussed about the finding the factors, isn't it? You all know the quadratic polynomial and how to factorize it, like middle term splitting. Okay, and here, if you given the zeros, how will you form the polynomial? Forming polynomial given zeros. So when zeros are given, how will you form the polynomial? Okay, very small and very short topic. Yes, Pulkit, good afternoon. Asta, good afternoon. And I think Prathamesh is there. Good afternoon, all of you. So let's connect with the class and let's begin. I think some network issues, like many of you joined later. So is there some network issues why children are not coming on time? Because you all are aware that I've already given the schedule at 3 o'clock. Okay, so I'll send you the link in case you missed the previous part. Okay, so let's begin with a very simple topic, formation of polynomial when zeros are given to you. Now, when we compare the x squared plus bx plus c and it has two zeros, so we assume that let the zeros be alpha and beta. One generalization, the quadratic polynomial is ax squared bx plus c, and then it has two zeros. We call one zero is alpha and the other zero is beta. So this will be the generalization we take it. So if now you're given with the zeros alpha and beta, so what do you call this middle term here is? Okay. So how to get the formula? First, I'll give you the example and then we will generalize it. A very simple topic, so can you pay attention and understand the concept? I'm taking two examples for it, and using these two examples, we will generalize it. So please let's see. You all know how to do middle term splitting, so I'm taking one of the simplest examples. So here, the first example is x squared minus x minus 6. So you all know the factors of it. Come on, quickly. I think you have your rough book handy. Quickly factorize it. Okay, these are the two examples. So quickly you can try to factorize it. I hope you kept your pen and book handy so that you can try the rough book. Okay, so you can go ahead and I'm doing it here. So let's check it out whether you will be getting the same answer. So when you factorize it, 6. So the factors of 6 is 2 3s are. So we get here. So it is x squared minus 3x plus 2x minus 6. So x minus 3 into x plus 2. Do you all get this? Okay, correct. Now let's go with the other one. Okay. It is 18 3 are 54. When I say 54, it will be the factors. So 3x squared minus 9x plus 6x minus 18. So it is 3x. So what is common here? X minus 3 plus here 6x minus 18. If I take 6 common, I get here x minus 3. So in short, I get this as, and looking at this, if you could see this, what is common? So did you notice something here? Okay, I hope you pay attention here. Did you notice the factors in both the cases? Okay, see the polynomials are different, but you could see the factors are here we got the factors as x minus 3 and x plus 2. And here also we get the factors x minus 3 and x plus 2. So if I compare it with 0, so what will be the zeros of both the polynomials? Will it be same? What are the zeros of the polynomial? Yeah, many of you are right. Who's this? Janvi, I think something is wrong. Could you check it, please? Okay, yes, most of you are correct. So, what are the zeros of both the polynomials? Yes, so when you compare this both the brackets as 0, so x minus 3 0 or x plus 2 0. So, what do we get? Either we get x plus 3 and I get x plus minus 2, isn't it? Yes, Aditya, it's correct. It is 3 and minus 2. Aska, be careful about signs. Okay, so that means two different polynomials are there, but still we get the same zeros, isn't it? So it may be possible that if you're given with the zeros, there could be more than one polynomial possible for it. I hope you got my statement. If you're given two zeros, it might happen that it could be the zeros of more than one type of polynomial, isn't it? Because if I'm giving you x is equal to 3 and x minus 2, you could say here two polynomials are giving the same answer. I hope you get this. So that means, how will I generalize it? Okay, so please look at it. Now I'm just going with the reverse mode. Pay attention. The steps are not very important, but the mental working is important here. So how to think about it? A very simple concept is this, so not to worry. Now, that means if you're given, here the question starts. Our question is formation of polynomials. So when you're given the zeros, so if the zeros are x is equal to 3 and x is equal to minus 2, what would be the polynomial? Okay, so here it goes. Look at the reverse topic. 3 and minus 2 are the zeros. So if I reverse it, zeros to factors. You remember your remainder and factor theorem of class 9. So x is equal to 3 is a 0. That means x minus 3 is a factor. Similarly, x is equal to minus 2 is a 0. That means x plus 2 is a factor. I hope you got this concept. Remember this? Okay, so that means product of these two, okay, would give me the polynomial. Very simple, but what about this? Here also, I have the zeros, x is equal to 3 and x minus 2. So to generalize this, I will derive a formula of a polynomial that if 3 and minus 2 are the zeros of the polynomial. So in general, if alpha and beta are zeros of the polynomial, then px will be equal to k times x minus alpha into x minus beta. And what does this k mean? It could be any real number. Because if you multiply this whole polynomial by 2, you get a new polynomial, but the zeros will be same. You may multiply this polynomial by 1 by 0.2. If any real number in general, you get the same zeros as the answer. Okay, so that means when alpha and beta are the zeros of the polynomial, did you get this? Okay, so this is the formula. I just explained you that for understanding the formula. If Px is any polynomial, to get any polynomial, when we are given the zeros, so suppose alpha and beta are the zeros of the polynomial, then Px will be equal to k times x minus alpha into x minus beta. I hope you got the why this k over here. Okay, many of the books doesn't show the k, but it has to be there because k is any multiple. Though you get the different polynomials, but the zeros remain the same. So you could note down this. When alpha and beta are the zeros of the polynomial will be k times x minus alpha into x minus beta. I hope it's clear. Alpha and beta are any real numbers. Okay, this is the formula. We'll be dealing with the sums, so I think answer your doubt to be clear. Okay, now now you're going to do it. So I'm giving you one example. Let alpha be -2 and beta be -3. Tell me the polynomial. Yes, k is any constant, that is yes, real value. Any real number. Constant means yes, any real number. So I hope you're getting it. I know you won't be able to write it properly, but you can check it when I'm solving it. I'm just giving you few seconds to solve it. Okay, so now how will you do it? Very simple. Px is a times x minus. Now answer your doubt. I hope it's getting clear. Alpha is -2 into x minus -3. Okay, so it is k times. It becomes x plus 2 into x plus 3. So this is nothing but k times. When you simplify this, expand it, what do you get? X squared plus 5x plus 6. I think quite simple. Yes, correct. Yes, Aditya. But you have to write down in the expanded form. So don't leave your answer here, otherwise your marks will be deducted. Or it could be rectangular because if you expand it, okay, if you expand it, you get this as k times x square minus okay. So any way you could use it, you get the same answer. So if I use it here like this way, okay, then how will I write this? It is k times x square minus 2 plus minus 3 times x. Okay, so what I get it? So k times x square minus 2 minus 3. It becomes minus 5 into minus so plus 5x plus 6. I hope it's clear. I'm waiting for your comments so that I can go ahead with you and practice for the sums I would give you in our WhatsApp group. So I'm just waiting for your reply, whether yes or you need one more example. But I said we are writing in general. So k could be any real number. So you can just leave it like this that px is equal to k and k is any real number. That's all. This is the answer because you're generalizing the answer. You don't know because there are so many polynomials. There could be infinite polynomials. For example, you multiply this by 2. The answer would be same. The zeros will be same. 2 and 3. I mean, minus 2 and minus 3. You multiply by 3. You multiply by 4. You multiply by half. You multiply by minus any negative number. It would be same. Okay. Okay. Take down one more example. The zeros are I'm writing down this formula because like what Aditya did, it could be that you just put it in multiplication form and you can you leave it. You should not forget. You have to write down in expanded form. Okay, let's take one more example. Let alpha be 1 by 2 and beta be minus 1 by 3. Come on, let's do it. But complex. Come on, try this. So, such. substituting here x squared. We said, how would you write this as? Okay, you can take LCM and you can write this equation as a times, so that is 6x squared minus 2x minus 1 upon 6. Okay, so you can take that k and then you can take this k out and write one more time as I hope it's clear. Okay, I know it's very simple concept. It might come as in MCQ or very short, or it could be for 2 marks question answer. Okay. Now, if you remember, I told you to focus on class 9 concept, that is remainder and factor theorem. So we are going to make use of it here, and we are going to go with cubic polynomial. So I'll send you the notes later about solving the sums or solve sums and practice questions also. Okay. Now we go ahead with other concepts. Okay. Now we are dealing with your class 9 concept only. So please quickly verify 3 is a factor of x squared minus 5x plus 6. I'm taking very simple polynomials here so that first you understand the concept. 3 is a factor of x squared minus 5x plus 6. Okay. So what is our px here? X squared minus 5x plus 6. So I hope you remember. You have to use your remainder and factor theorem. And what remainder theorem says that if x minus a is a divisor, okay, then you substitute a, that is find p of a. That is instead of x you substitute a. X की जगह पे आपको a रखना है, okay, and find the value. Okay, so that comes as the remainder. Instead of doing the whole division, I hope you remember your class 9 concept. Instead of doing the whole division, the shorter is you substitute the value. Okay, when it deals with a binomial, right? So when x minus a is a binomial, then p of a gives you the remainder. And when this p of a comes 0, x minus a is a factor. So we are going to make use of same class 9 concept here. So by remainder theorem, or check the comments. What would be the value? So it is 9 minus 15 plus 6. So it is 9 plus 6, 15 minus 15. This is 0. Therefore, P of 3 is equal to 0. And therefore, by factor theorem, 3 is a 0 of, like, I hope you know this, 0 or factor like 3 is a 0 of given px. I hope it is clear. Yes. So very clear. I know, very simple. You have done the same in class 9. But now I'm talking about the cubic polynomial. So we need to do that. Okay. Please follow copy down the question. When you not copy, just understand how it is done. Okay, so come on. Here also the same way using remainder and factor theorem. So we'll try that. Now it is minus 1. So P of minus 1. What is the answer here? Try it please. And what is P of 2? Try it. Yes, what is P of minus 1 and what is P of 2? Yes, are you trying? Still the number is 24. That means others are either sleeping or they felt it boring or the network issues. What is the problem? Yes, I'm waiting for the answers. What is P of minus 1 and what is P of 2? You're getting it. So in my question was what is P of minus 2? What is P of 2 and what is P of minus 1? Yes. Aditya is getting P of minus 1 is minus 15. Okay. So minus 1, let's verify, is minus 1, minus 1 cube. Minus 1 squared, it becomes a positive 1 with minus 6, minus 11 and minus 6. So minus 6, minus 12, minus 13. What are you getting it? You said it is minus 15. Can you check it? Both are factors. I didn't ask you about the factors right now. I'm saying what are the values of P of minus 1 and P of 2. Come on. Tell me the values first. I want to see how you're substituting. Okay, P of 2 is 0. What about P of minus 1? Rathamesh. Would you get it? Minus 1 cube. See, please remember. 1 raised to any power is going to be 1. Okay. But when it is minus 1, you have to be careful that you have to just check whether odd power or even power. If the power is odd, answer is minus 1. If the power is even, answer is plus 1. So this is minus 1. So minus 11, minus 6, 17 and 6, 23, 23 and 124. That is negative 24. Very true. I think one student has given the correct answer. And here you get this as 8. This is 6 4s are 24. Then 22 minus 6. So minus 24 and 6, 30. 22 and 30. So you will get 0. So yes, P of 2 is 0. You know how to write the steps. I'm just trying to cut down the steps right now. Okay. So, what would you conclude? Yes, minus 1 is not a 0, whereas 2 is a 0. Okay. Similarly, if I try with P of 1 and P of 3, put it down quickly. P of 1 and P of 3. Yeah, you got it right. Now I want you to check for P of 1 and P of 3. Correct. Yes, Janvi, correct. She got P of 1 as 0, right? What about P of 3? Very true, Samar. P of 1 is 0. What is it? P of 1 is P? I think 0. You were going to write 0 and you wrote right. Right. Okay. Right. P of 3. Very true. And even P of 3, what are you getting? Anyone with P of 3? Janvi, it is 18. Just check it, please. Is it 27? 3 3 9 minus 54 plus 33 minus 6. Yes? Yeah. Samad correct. Yes, Pratmesh correct. Rishikesh, check it quickly. You people are making mistake in signs. When you're finding the cubes and the squares, I think you're making mistake with the signs and that's why you're not getting the answer. Pratmesh, what was your mistake? I think same. No, I think Pratmesh is correct. Rishikesh and Janvi. One is getting 18, one is getting minus 18. Ask the same. It means same mistakes is repeated by you. Be careful. Yes, you all are getting correct answer. I think most of you are correct now. You're getting P of 3 as 0. Right? So now pay attention here. So that means 1, 2 and 3 are zeros. Okay. Now, in last session we took a quadratic polynomial and we checked for the relationship. Here I'm showing you with the cubic polynomial. Though it doesn't come in the exams frequently, but since it's a part of syllabus and we never know the changing pattern of CBSE board, so we would do this sum. So please understand a very simple thing because I think you have done with the quadratic polynomial, you have practiced the relationship how to find it out. So just remember here, and then once I give you in the written format, go through the steps. Okay, so quickly you just look at it what I'm doing. Okay, and try to remember this. Okay, so 1, 2, 3 are zeros. So now we have to verify relationship. Okay, and this relationship will be, I'll take it at 1 and alpha, second and here gamma. Okay, and what is the relationship here? It is alpha plus beta plus gamma. Okay, it is alpha beta. Okay, it is sum of the zeros and then cyclic product. You can say like A, B, C, then A, B, B, C, A, C, cyclic group. And alpha into beta into gamma. Let's see what is it. Okay. So you are aware of it. Could you tell me the first one? It's very simple. 1 plus 2 plus 3. So 6. 1 into 2 plus 2 into 3 plus 3 into 1. So it is 2 plus 6 plus 2 plus 6 plus 3. So 11. And the last one is 1 into 2 into 3. So 6. Okay. And now comparing with general form. Comparing with general form. And here what was the general form? Ax cubed bx square plus cx plus b. So what is a? 1 minus 6, 11, and this is again minus 6. Okay. I am repeating again. This doesn't come in the board exam. hardly have seen in the last 10 years board papers, but just it's a part of our syllabus, so we would be doing it. So now let's check for minus b by a, c by a, and minus d by a. I'm not writing in the word form, it's quite clear. So minus b upon a. So minus of minus 6, it's 1. So 6, c upon a. C is 11 and minus d upon a, minus d. So minus of, so 6. So I hope you could compute this. Okay, so alpha plus beta plus gamma. Minus b by a, and when we compare this statement, what do you get? Alpha plus beta plus gamma is equal to minus b by a. Alpha into beta plus beta into gamma plus gamma into alpha is equal to c by a. And alpha into beta into gamma is minus d upon a. I hope you don't get panic, bit lengthy sum, but generally it doesn't ask in the papers. Okay, but again the patterns are changing, the type of questions are changing, so we never know. So you should know this. I hope it's clear. Okay, I'll give you in the presentation written form so you would be clear about the concept. I think you know what to do it, just formula here. Then tell us what is quadratic form, what is cubic polynomial is a general form, and this relationship. The first is same, second is same, and the third is one negative, positive, negative. You can remember like this. I hope it's clear. And now I'm going with, I hope it's really understood by you. Yes, children? And one simple sum before winding up the session, which one of the important question comes in 2 marks. Okay? Again, you would see this is the repetition of your class 9. Okay? I'm taking now the same polynomial, but just one thing I'm changing. Could you do this? Do you remember this question? You've done it in class 9. I think time runs very fast. When I look at the timing, I feel you're looking. It took such a long time. I hope it's not boring. Quickly, you could try this. May I know which concept you are going to use it here? Anyone? What would be your first line for this? Okay, for solution. You all know the answer here. But again, the presentation part matters here. Because I've seen many of the students, we feel that, okay, very simple concept and they hurriedly write and they make mistake. So I want to ask you, like, what would be your first line over here? And which concept you are going to use it here? I hope you got my question. I hope this time taking you understand, because I want you to communicate, I want you to answer, I want you to reply. So please, do you remember which concept we are using it here? Just now we did it in the previous one of the previous questions. So how will you start? What should be your first line? Or which concept? I don't want the answer. I want you to tell me that, like, my question is which concept we are going to use. Achha, bit correct. No. Because you're given with something, Jani. What are you given with? You're already given that it's a 0. And it's a 0 means you know what is it, like what is a factor? Come on, I already gave you the hint. Yes, Athar. I know you're right, your answer is correct, but my question is which theorem we are going to use? I didn't understand this P of 2 is 5. Why P of 2 is 5 here? It's a 0 of the polynomial. Okay, look here, please. This is the polynomial. Okay, and you're given that 2 is a 0 of px. That means x minus 2 is a factor of px. I hope you are clear with this line. Yes, very correct, Rishikesh. That is factor theorem. And therefore, by factor theorem, what do we know? P of 2 is 0. So now, when you substitute here, so P of 2 is 0, that means everywhere, wherever x is, the value of x is, it is substituted by value of x is 2. Yes, it is not remainder theorem, it is a factor theorem because we know what that it is a 0. So you could skip this line also. We don't need this also. It's a 0 and hence you can say by factor theorem P of 2 is 0. You can skip this line also. Okay, so when we solve it, P of 2 is 0. No hurry, please. You are getting hurry and you're making mistake. Please pay attention. P of 2 is 0. When it comes to solving, you have to be very careful, please. P of 2 is 0. So the substitute the value now. So 2 cube minus 6 into 2 square plus 8 times 2 minus 6 is equal to 0. Come on. What it would be? You know the answer already. I gave you the same polynomial. I'm continuing with the same polynomial. So 2 cube is 8. 2 ka square. I hope you remember gold marks. First power. So 2 square is 4. 4 6 are 24 plus 2 times k minus 6 is equal to 0. That is, so 8 minus 6, 2. Okay, so minus 22 plus 2k is equal to 0. And I bring this here. And hence we get k is equal to 11. 11 is correct. Yes, 11 is correct answer. Okay, yes, k is equal to 11. But again, children, see what I'm saying. That I know the sum is very simple. I think somebody's there. K is 12. No, k is not 13. It is k is equal to 11. You could see the solution here. But again, my focus here on the presentation. I have seen many of the students most of the time, in spite of doing the correction and in spite of repeating the things that be careful about the statement. Okay, they forget this. Okay, and they just simply substitute the value, and all of a sudden somewhere they get k is equal to 11. So though everything is correct, you don't get the full marks in the paper. So please remember the first line here that since it's a 0, what are you given with? Either factor or 0. You will say that by factor theorem, it has to be 0. So you get something like equation and then you get the value. Prathamesh, be careful. The value is wrong. You check the solution. So I hope that in today's session, we did 2 to 3 different kind of sums. One is formation of polynomial. Second, verification of cubic polynomial. And the third is checking whether it's a 0 or not. I hope it's clear. Okay. And for tomorrow's session, I'll give you the timings later in the group. And tomorrow we are going to deal with division of polynomials. Okay, I know it's one of the most important concepts, 3 to 4 marks, a sure question, and it's more of a writing work. So I request you that you keep your books handy if you have not even kept it today. Keep your notebook handy so you could try it. And before solving, my request would be when I solve it, you pay attention, and then when it goes with the second round, you can try your own. And please revise this. I'm sending you the link so now you can repeat. You can watch it if you want to see again or you want to clear your concept. You can repeat this video. Okay. Thank you, children. Thanks a lot.